A vernal pool is a contained depression in the ground that fills up with water by rain, which then turns into snow and ice in the winter. When spring comes around, the vernal pool water level rises from the melting snow, runoff, and rain. By late summer, a vernal pool is generally dry. In some unique cases, like the old swimming pool at Berkshire School, the vernal pool never dries up and has an inlet where water pours into. Frogs and salamanders enter the vernal pools to mate in the early spring when the temperature is warm enough and the water level is high. Vernal pools are ideal places for frogs and salamanders to reproduce because there are very few predators and no fish. The main battle for survival is whether or not the tadpoles will develop fast enough before the vernal pool dries. Wood frogs are generally the first to make their ways to the vernal pools in the spring. If you listen to the video, the males are giving off mating calls which sound similar to a quacking duck. The male is smaller than the female, and when he finds a mate, he wraps his arms around the female and squeezes her belly, forcing the eggs out. As the eggs come out, the male frog fertilizes them. Once the wood frog eggs are laid, it can take as few as 4 to 7.5 days depending on temperature for the eggs to hatch. Once the tadpoles are hatched, metamorphosis of the wood frogs generally occur 45 to 80 days after the eggs are laid. What Zach and I want to find out is whether or not temperature and dissolved oxygen will have an effect on the tadpole's development.
We believe that the vernal pool with a higher temperature will have higher amounts of dissolved oxygen, and the tadpoles will develop at faster rates.
We went about testing this hypothesis by taking measurements of the newly hatched tadpoles each week and recording the temperature and dissolved oxygen. By taking the averages of the dissolved oxygen and temperature and comparing them in relation to tadpole growth and development, we could conclude whether or not dissolved oxygen and temperature had an effect on the tadpole growth. Once you have mixed the dissolved oxygen test packets into the sample, you drop the sodium thiosulfate standard solution 1 drop at a time in the brownish sample until the sample becomes colorless. The number of drops it takes for the solution to become clear is the number of milligrams per liter of dissolved oxygen. In this test, the oxygen level of the water was 5 milligrams per liter.
As far as averages go, the old swimming pool had a great temperature. However, the vernal pool behind Clough's house had greater fluctuations in temperature because the volume of water is less.
The dissolved oxygen levels of the old swimming pool were mostly higher, which followed our hypothesis because the swimming pool also had a greater temperature. However, there is also an inlet where excess water dumps into the swimming pool, which helps oxygenate the water.
The tadpole growth is where our hypothesis got screwed up. We thought that tadpoles that were living under conditions with higher temperatures and greater levels of oxygen would develop faster. However, from the data we found, the tadpoles at the Clough's house grew at faster rates than the tadpoles at the old swimming pool.
Because of the fluctuations at the vernal pool behind the Clough's house were so great, we believed that our hypothesis could still be correct. We mostly took data in the morning when the temperature was cool, and because the volume of water in the vernal pool behind Clough's house is much lower than the old swimming pool, the vernal pool is much more susceptible to change in temperature and dissolved oxygen as the day goes on and becomes warmer. If we had taken more data in the afternoon, we believe that the temperature of the water and dissolved oxygen levels would increase dramatically in the Clough's house vernal pool, whereas the old swimming pool would stay relatively the same.
Dashing through the snow on a pair of broken skis. Over the hills we go, crashing into trees. Ha ha ha! So it's turning red, and I am almost dead. I'm going to the hospital with staples in my head. Hey!
Yeah, you know.
Oh my god.